Welcome everybody. In today's tutorial we're going to take a slightly alternative look at multiplication and what that means. The way we're going to do it is from a graphical or a kind of geometric point of view, and we're going to use this to do something really cool and interesting, which is to establish the relationship between imaginary numbers and real numbers. Let's start off with a very simple multiplication example. So we'll take something that you have been able to do probably for quite some time now, and that's take the number 1 and multiply it by 2. And we know that our answer is going to be 2 or positive 2, whatever way we want to think about it. But the way that I would like you to start thinking about multiplication is in a geometric sense. So to show you what I mean by that, I'm going to paste in a number line here and just explain to you what multiplication does to a number. So to start off with, I'm going to start off with the number 1. Okay, I'm going to represent that on my number line by an arrow centered on 0, okay, of length 1. And when I multiply that by 2, we can clearly see that I get a new number which is twice as long as my old number. So as well as just thinking about multiplication in an arithmetic sense, we can also think about it geometrically in terms of what it does to the number. So there are two things which multiplication does to a number. The first is that it scales a number. So what do I mean by that? Well, very simply, it either stretches it or it compresses it. Okay, so it scales the number. And the second thing it does, although it's not immediately obvious from this example, is that it rotates the number. Okay, now how much does it rotate it by? Well, it rotates it by the angle of the number we're multiplying by. So the number 2 is the number we're multiplying by here. What angle does that make? With my number line, it makes an angle of 0 degrees. So in other words, the reason why we don't really notice the rotation here is because the rotation is in fact 0. But this is a very different way of thinking about multiplication, but it's a very useful way of thinking about it. You can visualize multiplication as a scaling of a number and also a rotation of a number. If we take another example, we'll say we start with the number 2 and we multiply it by 3. Again, we know the answer to that is going to be positive 6. But in this new way of thinking about multiplication, we could think about this as scaling it or stretching it by a factor of 3. And again, rotating it by the angle that 3 makes with my number line. So that angle is 0 degrees, so I'm not really rotating it at all. So I can represent this on my number line just like I did in the previous example. So we start off with our number 2, and when I multiply it by 3, I'm going to scale it by a factor of 3, and that's going to produce a new number which is 3 times longer, and it's rotated by 0 degrees, so it points in the same direction as my original number. This becomes a little bit more interesting when we look at examples where we're multiplying not by a positive real number, but this time by a negative real number. So we'll take 1 and we'll multiply it this time by negative 2. And again, we know our answer should be negative 2 when we do this. But geometrically or graphically, how can I think of this? Well, again, I should understand this as scaling or stretching by a factor of 2. And also a rotation by the angle of my multiplier negative 2. So what angle does negative 2 make? Well, that makes an angle of 180 degrees with my number line. So hence when I multiply 1 by negative 2, my answer will be a number which is twice as big and which has been rotated by 180 degrees. So if we look at this on our number line, so again, we'll start off with 1 represented by my arrow of unit length, And when we multiply that by -2, we're going to double the length of it and rotate it by 180 degrees, and that's going to produce a new number which exists here on my number line. So I can clearly see that multiplying by -2 is a rotation of 180 degrees and a stretching by a factor of 2. Now you might like to go and practice some more examples of this, so just choose any number and multiply it by another number and see if you can picture it or describe it in terms of a scaling and a rotation. I'm going to go on now and I'm going to look at slightly more interesting examples. So I'm going to look at what happens when I take 1 and I multiply it by -2 twice. Or in other words, 1 multiplied by -2 squared. Now again, if I go to my calculator or I just do it in my head myself, I know that my answer to this is going to be 4. But can I understand this in the sense of a scaling and a rotation? Well, I can very easily. So 1 by -2 squared could be thought of as 1 by -2. And then when we work that out, we're going to multiply by another -2. So how does this fit in with our picture of scaling and rotation? Well, here, this is going to scale by a factor of 2. And it's going to rotate by 180, since -2 makes an angle of 180 with my number line. Okay, so when that's done, then whatever I get, I'm going to have to multiply that by another -2, so that's going to have the effect of scaling that by a factor of 2 and rotating it again by 180 degrees. So if I get my number line, I can represent that very easily. So again, we'll start off at 1 and we'll do the first part of our operation, which is scaling by 2 and rotating by 180 degrees. So that's going to produce this number here. Okay, so my rotation of 180 degrees. And then that number is also going to be multiplied by -2. And when I do that, I'm going to scale that by 2 and rotate it by another 180 degrees. And I'm going to end up with an answer of +4. So this way of thinking about multiplication is also useful when it comes to working with indices or powers. It helps us figure out what the sign of our answer is and also what the size of our answer should be. We can extend this and look at more complicated examples. So if we take something like 1 multiplied by -2 to the power of 3. So again, if we go to our calculator, we will get an answer of -8 for that. So can we think about this in terms of rotations and scales? Well, this can be thought of as 1 by -2. And then whatever I get there, I'm going to multiply by another -2. And whatever I get there, I'm going to multiply by another -2. Okay, so each time I multiply by -2, I'm going to scale by a factor of 2 and rotate by 180 degrees, since -2 forms an angle of 180 degrees with my number line. So let's represent that nice and quickly on my number line. So I'll paste it in there, and again we'll start off with 1 multiplied by -2 is going to produce -2. So that's my scaling of 2 and rotation of 180 degrees. Then when I multiply by the other -2, the next -2, again that's going to scale by a factor of 2 and rotate by 180 degrees, and that's going to produce +4. And then I have to do a multiplication a third time by -2, and when I do that, again I'm going to rotate by 180. And I'm going to scale by a factor of 2, and when I do so, I'm going to get an answer of -8, which is in keeping with what I would expect to get. But again, by thinking about multiplication in terms of scales and rotations, I can get to my answer using a very nice geometric approach. Again, you might like to go on and do some more practice on this just to get your head around thinking about multiplication in this way. But I'm going to move on, and I'm going to use this approach to establish a relationship between two different types of numbers. They are the real numbers. So you've been familiar with real numbers for a long time now. You've been using them pretty much all your life. But a new type of number that you've recently been introduced to are imaginary numbers. Okay, so imaginary numbers are numbers which allow us to deal with negative square roots. Okay, so I'm going to show you how imaginary numbers and real numbers are related to each other, not just algebraically in the sense of this definition here, but geometrically. So I'm going to use multiplication and this particular view of multiplication to help us understand how imaginary numbers are related to real numbers. So let's take another multiplication example. And the example that I'm going to use is 1 multiplied by I squared. Okay. Now we can work this out numerically very easily. So I squared means -1, so that really is 1 multiplied by -1, which we know is an answer of -1. Thinking about it in terms of scales and rotations, this is a scaling of 1, or no scaling at all. In other words, the number is still the same size, and it's a rotation of 180 degrees, since -1 makes an angle of 180 degrees with my number line. We can use this result to understand the relationship between imaginary numbers and the real number line. So how can we do this? Well, let's consider this simple multiplication. So instead of 1 by I squared, we're going to look at 1 by I. Now, our knowledge of algebra suggests to us that the answer to that should be 1I, or simply I. But what does that mean geometrically? What does that mean in terms of our number line? Well, if 1 multiplied by I squared is no scaling, but a rotation of 180 degrees, then 1 by I again must be no scaling and a rotation of 90 degrees. So how can I say that? Well, 1 by I squared would be double that rotation, or 2 90s, or 180 degrees. So 1 by I must be a rotation of 90 degrees. Now let's look at what this means for our number line and representing imaginary numbers on our number line. So I'll paste our number line in here. And again, we'll start off with our number 1. So represented here on my number line, and when I multiply that by I, what's it going to do to it? Well, it's not going to scale it, it's not going to change its size, but it is going to rotate it, and it's going to rotate it by 90 degrees. So where does I exist on my number line? Well, it's not on my real number line at all. It's actually on a line which is 90 degrees to my real number line. So here is where I is located in relation to my real number line. So what I'm creating here is a brand new axis, a brand new number line, and this is my imaginary number line. And when I look at multiplication by 2i, I'll find scaling of 2 and rotation of 90 degrees, and that means 2i is located here, 3i is located here, and we can extend this idea to understand that -I exists here, -2i exists here, -3i exists here, and so on. So what I've created is a brand new number line, my imaginary number line. Now this number line doesn't exist in some arbitrary space. It exists in a very specific space, and that is the space which is at 90 degrees to my real number line. No doubt you'll have seen this diagram in all your textbooks. It's called an Argand diagram. But often it's presented as fact instead of understanding that when you look at multiplication in a very particular way, it shows us that our imaginary axis must lie at 90 degrees to our real axis.